Hi. In this video, I'll show you how to create your own function in Excel called a user-defined function, or UDF. To get started, we need to open Excel's built-in VBA editor. By default, this option isn't available on the ribbon. To make it accessible, click the Customize Quick Access toolbar drop-down at the top of the Excel window and choose More Commands. In the Excel Options dialog, change the drop-down to All Commands, then scroll down and select Visual Basic Editor. Click Add to move it to the toolbar, then click OK. Now, the Visual Basic Editor icon will appear in the title bar, ready for quick access. Press Alt F11 or click the Visual Basic Editor icon. This opens the VBA editor. Go to the Insert menu and choose Module. A new VBA module will be inserted, and its code window will appear. Let's write our first custom function. It's a very simple one. It just returns the text hi. Every function starts with the keyword function, followed by a name you choose. It ends with end function. Just like built-in Excel functions, a UDF returns a result. Inside the function, we return the output by assigning it to the function's name. So this line tells Excel to return hi when you type into a cell. Let's try it out. Go back to Excel and type function say hi into a cell. When you press enter, the cell displays hi. That's the return value from our function. Functions don't just return outputs. They can also take inputs, called arguments. Let's modify our function to accept an input. We'll define an argument called name inside the parentheses of the function declaration. Next, we'll use this argument to return a personalized greeting by combining it with the text hi. In VBA, the and symbol is used to join or concatenate text strings or variables together. Let's write the function and pass it the argument brainbell. When you press enter, the function returns hi brainbell. You might notice that any cell where you previously entered the function say hi now shows a value error. That's because the function has been updated to require an argument. To fix the error, just update the formula by passing a value for that argument. Functions aren't limited to a single argument. You can use as many as you need. Just separate each argument with a comma. Let's add a second argument called message, which we'll use for a custom message. We'll also concatenate this new argument along with the name to return a full greeting. Now, you need to pass two arguments. First, the person's name, and second, the greeting message. For example, when you pass John and welcome, the function returns, hi John, welcome. Again, the previous formulas that used just one argument will now display a value error because the function has been updated to expect two inputs. Make sure to update any older formulas to include both arguments. You can also make arguments optional, which is perfect for situations where an argument isn't always required. If you don't provide a value for an optional argument, the function will still work and won't return error. In VBA, you do this using the optional keyword in the function definition. When using optional, you also need to specify a default value for that argument. This default value is used when the argument is not provided in the formula. Let's make the message argument optional by assigning it a default value, an empty string. Now, if no value is passed for the second argument, the function will simply return a basic greeting. Now, you can call the function with just one argument, Nick, and it will return, hi Nick. If you do provide the second argument, good morning, then it will return, hi Nick, welcome. Optional arguments give your function more flexibility by allowing users to skip inputs they may not always need. Keep in mind, when you declare an argument as optional, then every argument that follows it in the function definition must also be optional. If you don't follow this rule, VBA will show a compile error. Let's see how this works by adding a third argument called score. We'll assign it a default value of 0. If you try to add score without marking it as optional, VBA throws a compile error. So, once you make one argument optional, all arguments after that must also be optional. Now the function has 3 arguments. You must provide the name argument. But if you don't provide message or score, the function uses their default values. When you call a function with an optional argument, you can choose whether to supply a value or let it use the default value defined in the function. It's easy to omit the optional argument if it's the last one. You just leave it out, and VBA uses the default. But what if the optional argument is in the middle, and you still want to provide a value for a later argument? For example, in our function, message is the second argument and optional, while score is the third. Now imagine you want to skip the message, but still provide a score. It's easy. Just use a blank placeholder. The two commas tell Excel that skip the second argument and move on to the third. Notice that the function returns default values in the output when you don't supply certain optional arguments. But sometimes, you might want the function to only process and display those optional values if you explicitly provide them. For example, let's say you only want to show the score in the output if it was actually passed in, not if it's just using the default of 0. To do that, we can use the if and else condition in the function. We'll check the value of score. If the value is 0, which is the default, we assume the user didn't provide it, so we skip it. If the value is not 0, we include it in the result. Now, when you update the formulas in Excel, the message "your score is 0" no longer appears on the sheet. This way, the function adapts dynamically based on whether or not the optional value was explicitly passed in. Next, let's talk about data types for arguments and return values. Data types define the kind of data a variable can store, like numbers, text, or dates. The table on screen shows some common VBA data types. In our current function, we haven't declared any data types. When you don't specify a data type in VBA, it automatically assigns the variant type, which can hold any kind of data. While this offers flexibility, it can slow down performance and lead to unexpected behavior. For example, if we expect a numeric value like 50 for the score argument, but someone types 50 using letters, the function will still accept it without any error. That's because the argument is treated as a variant, not specifically as a number. To avoid this kind of issue, we should explicitly declare a data type for the score argument so it only accepts numeric values. Let's go back to the VBA editor and update the argument by writing as integer after the name score. Now, the function expects a whole number for the score, and if you enter a text value instead, Excel will return a value error. Now, try it on a sheet. When you enter text instead of a number for the score argument, the function returns a value error. But when you enter a valid number, the function runs correctly and returns the expected result. It's a good practice to declare data types for all arguments. Let's go back to the VBA editor and declare string as the data type for both the name and message arguments since they take text values. You can also specify a data type for the return value of the function. To do this, place the return type after the closing parenthesis. For example, since our function returns text, we write as string after the parentheses. Declaring data types not only helps prevent errors, but also improves the performance of your workbook. To test the return data type, let's temporarily change it from string to integer. Now, we've explicitly declared the return type as integer instead of string. When you test the function on the sheet, it returns a value error because the function is actually returning a text value, not a number. Let's change it back to string to fix the error. This example shows how declaring the correct data types for arguments and return values helps reduce errors and prevent unexpected behavior. Another important concept in VBA functions is whether they're volatile or non-volatile. To understand this behavior, let's clear the sheet and start from scratch. We'll create a new function called static random. This is a simple one-liner function that returns the result of the RND function. The RND function generates a random number between 0 and 1, specifically a random double value. Now, let's try it out in Excel. When you enter equals static random in a cell, it returns a random number. But here's the key observation. Each time you enter the formula in a new cell, a new random number is generated only for that cell. For example, enter the formula in cell A1, you get a random number. Now enter the same formula in A2. It gives a new random number, but A1 stays unchanged. Enter in A3. Again, a 1, and a 2 remain unchanged. Now let's compare this with Excel's built-in rand function. Enter rand in A5, you get a random number. Now enter the same function in A6. Not only do you get a new value in A6, but A5 updates too. When you enter the formula in A7, both A5 and A6 update again. This behavior is called volatility. A volatile function is recalculated every time any change happens in the worksheet. So, Excel's rand is a volatile function, whereas our static random is non-volatile. Its values do not change unless the formula is re-entered or recalculated directly. That's why we named it static random, because it produces random values that stay static after generation. Now let's go back to the VBA editor and enhance the function. We'll assign a data type to the return value, double, and we'll add an argument named max. Then we modify the return statement to multiply R&D with max. Now try it on the sheet. The argument value 10 returns a decimal between 0 and just under 10. The argument value 100 returns a decimal number between 0 and just under 100. Similarly, 1000 gives you a value from 0 to just under 1000. To return whole numbers instead of decimals, we can modify the function using the int function in VBA. Now, what does this updated version do? It generates a static random integer between 0 and a number just below the value you provide. For the value 10, it returns a whole number between 0 and 9. For the value 100, between 0 and 99. For the value 1000, between 0 and 999. This can be useful for simulations, static random IDs, testing, or when you want to generate random values that don't keep changing. But what if you want a user-defined function that behaves like a volatile function, updating itself every time the sheet recalculates? You can do that by adding application volatile line inside your function. Now, your function becomes volatile. It will update its result every time Excel recalculates, just like the built-in rand function. Try it again on the sheet. Now, every time you type or change a formula, all cells using static random update automatically. This is the power of understanding volatile versus non-volatile functions in VBA.